Hello everyone, and welcome to Greenfoot Basics Crash Course tutorial. In this video we're going to quickly go through some very basic programming concepts and allow you to get used to Greenfoot. If you have not had any experience programming, I would recommend going through and doing my 6-hour beginner course, but if not, this course might get you ready to get into more advanced Greenfoot topics quicker. In this Greenfoot course we're going to go through variables, if statements, constructor methods, classes, objects, loops, and even on to, at the very end, doing multi-dimensional arrays. So let's not waste any time and go ahead and get started.
Okay, so I'm going to start off by getting a new scenario, and I'm going to do a new Java scenario, and I'm just going to call it Crash Course. And so when you load up a new scenario, a new Java scenario, it will give a blank background that this is your interface. This is where you're going to be able to put your actors in and move them around. So if you want to right click on actor and create a new subclass, this will allow you to create different actors that can move around, and you're going to be able to manipulate them, and they are class names and they're of the actor type. So that's when you right click and you create a subclass of actor. And so if I go to people, I can go to our stick figure person here, and an actor doesn't show up on the screen automatically, and this is our my world, which is our background. And so our my world, if you want to change the image of any class, I want to change the image of my world. So I'm going to right click on it and set image. There are examples of different backgrounds you can use, and I'm going to go ahead and just do a more of a gray background just to give it a little bit of depth there. And so then you can also open the editor and you can add objects in manually through the constructor. Now a constructor is a little bit more intermediate of a topic, but that is what is created in the world. So this will create a new world, a 600 by 400. Prior to running the program, this is already pre-built. So if we want to add more things to it, you can by creating an add object of a new person, and you can give them their X value is needed and their Y value. Okay, and so this would be the code for adding in the new object. Now if you're new, you might want to use control space and search through some of these different methods that you are able to do. For example, the one we just used was this add object, and if you do control space and then enter on the one you highlight, it'll say, well, we need to add a new object, and it has to be of a class that you have created. So you have to spell it exactly like person. And so we have created a person at the center of the world. Now I'm going to pause and take a quick minute to talk about what we just created. We just put an object into our world of the class person type. Let's take a look. What we just created was a class. A class is a blueprint for creating objects. We created a class person, which was a subclass of our actor class. And so we'll talk a little bit more about subclasses later, but a specific class person, we created one object that was put in the center of our world. Here's an example where we could have a class dog, but we could have multiple dogs on the screen. So we could have dog 1 and dog 2, both objects of the class dog, may have very similar behaviors over here that we will describe with functions and methods, but might have many different states or attributes. So the class holds both the attributes and the behaviors of two different types of dogs. You may have a golden retriever versus a poodle that are different ages and different colors, but they would all have the same behaviors. They bark, sleep, eat. So these are some things you can manipulate when you're creating a class. And now we'll head back to the video. And our person can stand there, and we can have this person move around and do different things automatically if we would like. So first, just moving forward is a simple move command, and if you do control space, I really like to use that control space whenever I can. Makes it a lot easier to remember some of these methods. So if you do control space and move, will say that this is the distance you want the actor to move forward in number of pixels every time it cycles through this act method. So it will continuously cycle through this act method if you push run, but if you push act, it will just do it once, and you can see my player moving forward 4 pixels each. But if you hit run, that's when you have it in a loop and you can have a constant movement for maybe an enemy or a player or whatever you would really like to do. And so that move right there is a method, and we're going to talk real quick about what that method is capable of doing. So if you'll pause for a moment there. What is a method? A method in object-oriented programming is a procedure associated with a class. A method defines the behavior of the objects that are created from the class. A good example of a method is if you have a class car that you create and they have these different traits and attributes like make, model, miles per gallon, and mileage on the car. In Greenfoot, we're going to use this public void act method, which is the main method, and it will be called in a loop fashion most of the time when you're running your code. And then inside of this main method, we have created our own methods like drive, brake, turn, and honk. And once we write these methods, every object of the class car will have these behaviors and abilities. And now we will get back to the tutorial. We want to also experiment with not just moving forward, which this is their 0 rotation. We also want them to be able to move up and down and left and right. In order to have them move up and down and left and right, you would change it to set location. So if you do set location for this actor, we need a set. So if we looked up set location here, whoops. Okay, it shows that you need an X value and a Y value. And now if we just put in an X value and a Y value, it would relocate it and teleport it to that pixel spot. So 50-50 once we push act or run. And it would stop it there and hold it there because that's what is happening in the act method. So instead, how we use this in order for movement is we find the X value and the Y value that this actor is currently at, and then we manipulate that by moving it 3, and then so it moves it 3, and then it loops back up to the top of the act method and it finds that it's 3 further to the right, and then it adds 3 again and loops over and over and over again. So that will make it move forward. Now if we want to, this way we can manipulate it to move any direction, and you don't have to move forward necessarily. That just moved it to the right more than forward, and this will move it to the left. This would move it up and to the left, because I forgot to say this is 0, 0 up here. And this would move it just straight down. Okay, so you can manipulate this by using if greenfoot.isKey down, and we just have down. You have to put this in quotes. Greenfoot has to be capitalized, and this is getting something from the Greenfoot class, which is how we can read some user input of keys pressed. So down, up. Now, for now, this doesn't matter the order. The right and left, make sure it's not on the Y value. If we're going to move right, it has to be on the X value, and it has to be plus. And then make sure you change this to left, and you change this to -3 because it's moving towards that 0. Now, if you run this, this is an if statement. It will only move if you have the right, left, up, or down key pressed. So if we wanted to have another object, that could be our enemy, let's say, and let's have our enemy be a B. We could also add this enemy in the world, wow, they're big B's. We could have this enemy in the world by holding shift down and clicking it in, and that will add it into the world, but if we reset, it will remove it from the world. So if you want to keep them in the world, you would need to right click and save the world. Now Greenfoot automatically does something that's kind of interesting. It creates something we call a method, and this method gets moved and gets created down here, and it adds in enemy and enemy 2. Now the reason it has done this line of code is so that we can name a specific enemy. So we can have one of the enemies be enemy 1 and one of them be enemy 2. And so you have to what we call initialize the variable. We did not do that up here, but we really should get in the habit of doing that. You don't have to call it, you know, enemy 2 like they have. You call it main person equals new person. Just like we called this new person down here, we're going to call a variable called main person, so we give it a name, and it will be equal to new person, and it's of the class person that we created over here, of the subclass person. So instead of adding an object of any old new person that doesn't have a name, we can call it main person, and now we can specify in the code, hey, I want to find this main person's location. Or I want to, you know, if you want to reference main person instead of, you know, if you want to reference enemy 1 versus enemy 2, you would just type in enemy as opposed to enemy 2, and this new enemy would just be any old enemy, and you don't want to, you want to give those objects a name. So this would add a new object in, this would give it the name that we want. So what's cool about that is then we can actually reference all the things the enemy class is able to do. Like we can set the rotation of one specific enemy to 79 degrees. And then this one flips 79 degrees. And enemy 2 dot set rotation. Let's flip it 180. Okay, now we have enemy 2 facing left, enemy 1 facing down. Now the reason we're able to get this method set rotation, even though we haven't created it in the enemy class, is just the same way we get move. Move and a lot of the great thing about Greenfoot is that they have some stored methods and functions that we don't need to create. And so our actor class enemy is a subclass or extends the actor superclass, and you can see it here on the diagram. Enemy is off down and to the right because it is a subclass of the actor class. Now if we use that handy dandy control space or command space, you can look and see these are all the methods that are saved within the actor class. And so set rotation is the one that we used. And some methods that we create don't require anything in the parameter, any arguments we call it, and the parentheses we call the parameter. But some do, like move. If you need to know how the move it would have no idea how to do that command, that method, without having an integer value to say the distance in which you want to move. And so here you can say move this actor the specified distance in the direction it is currently facing. So that's why I recommend to look through these and you can see what they all do. Now you're not going to be able to use them right away because you're going to probably need some examples of how to use them, but they are very useful, and it's very cool to read through what we call the documentation or the API to see what all these terms are, or what all these methods do, and they help explain some things for you. So like here's the parameter for set rotation. It has to know the degrees in which you want to move, and so the int parameter would be the rotation in degrees. Okay, and so when I talk about an int, I might want to, instead of have it be speed, I could have, instead of have it being 4, I could have it being speed. If I create a variable for it that I will set the variable, so I could say int speed, and let's see if I need to give it a number. I don't. So as of right now. So if I run this, move speed will be 0. It just assumes it starts it at 0. But we could reference it in here if we wanted them to be different. I could say enemy.speed will start at least, so this prepare method happens at the beginning. So this happens right away. So it can set its speed equals 5. And then enemy2.speed equals 2. Okay, and so you see this one's much faster, and they both have their different speeds. Okay, another way you can do that is set the entire class's speeds. You could also do speed equals 7. Now let's see what that does. They both go at 7, so this will trump, because so this speed equals 7 will trump what we've set our speed in our prepare method, because notice this is not a public void act. This is entirely different. This is what we call a constructor, and a constructor is what builds your objects and sets up your world, in this case in the user interface. But this is how objects are created. So when we run the act method and we push run, it'll execute the program. And so when it executes the program, it will continuously run the act method, setting speed to 7 each and every time. So let's get that out of there. And now we can say we can access these enemies' position. Okay, so you can access the actor's X and Y value. So we could know the world is 0, the X value is 0, the Y value is 0, the X value is the width of the world, and the Y value is the height of the world. So that's what we're going to do now. And if our enemy get X, all of these gets have a return type. So a return type will tell you this has an int return type, a Boolean return type, and this int return type will return the X coordinate of the object's current location. And so this get X will access the X value, and this Y value will access the current Y value. So remember, this runs 60 times per second. So it's basically constantly checking the X value. So if the X value equals 0, you are on the left side of the world. And if you are on the left side of the world, we want speed equals negative speed. Now I could access the Y value if Y is 0 and the height and the width, but there is actually something in here that Greenfoot's already created for us that makes that even easier. Is at edge. So this will return a true is at edge. This will detect whether the actor has reached the edge of the world. Then return true if the actor is at or beyond the edge cell of the world. So is at edge. So if you're at the edge, you can say equals true, but that is monotonous, because if you just put is at edge, it assumes it's true. In order to say they are not at the edge, you would put an exclamation point. This would mean is at edge is false. So if I did it now, what do you think would happen? Well, the actor, enemy, would constantly be flipping back and forth because it would constantly not be at the edge of the world. See? So we don't want that, obviously. We want if it is at the edge. So that will bounce and bounce and bounce and bounce and bounce. Okay? So maybe we change the rotation. Just do a turn 20, and it will constantly keep checking the turn and swoop back and be a little bit more random on how it bounces off. So we just created some objects and we referenced those objects. So I wanted to go through and make sure you knew what an object was. So use keyword new to create an object or instance of a class. And so when we create the person class, we could create the main person, or we could have just given them a name like Bill, Steve, Nancy, and they each would have their own being within our code. And so whether you are writing with a user interface where you can see different graphics and things like that, or you're just creating a program, there's oftentimes when you need to reference specific objects within classes. So notice each of these cars are cars, but all have certain states, attributes, characteristics given to them. Okay. So real quick, public versus private, that's just how much access you are given outside of the class. So here is the visibility of each level. So oftentimes we'll be using public so we can reach it from any class, but there are times when private is necessary. But early on, it's really not very important for what we're doing. So hopefully you've noticed that you want to end each statement with a semicolon, and that those are some things that are easy to forget, is to put that semicolon at the end. So when not to use a semicolon are when you create a class, a method, if statement, or loop. And methods, when you're calling a method, you do want to have a semicolon. But when you are creating and building that method with the curly brackets, you will not need a semicolon. Okay, so here we have like our class name, the class person, and then we put in the information, the statements that we want. An if statement, you have the block of code, curly bracket, if this is true, if right is down, set location to the right. A return type, is at edge, will return true or false. So Boolean is at edge. A Boolean is of the true or false return type. We'll talk about that later. And a loop, same way. We'll go through that later. Okay, we've talked about subclasses and superclasses quite a bit now. Oftentimes you want to make superclasses so that both your code is more readable and more manageable, and also just to save time. And so if you had some very basic animal instinct code inside of your animal, that could be given to all of these different animals. Like all animals eat, sleep, drink. Okay, so that would be something that you could consider putting in the animal class so that they all inherit. So this is a superclass. Mammals are a subclass of animal, and a dog is a subclass of a mammal. Okay, so has hair, and reptile has scales, different things specific to them as well. So I mentioned the Greenfoot API as well. We can actually go in there by clicking on the world superclass, not my world subclass. And if you click on that and go to the tree hierarchy, you can find all the methods available in Greenfoot. You can also do that control space, and it'll pop up all the methods specific to the class that you're in. And we've been in the actor class the majority of the time. We also created a variable. Variables are used to store information to be referenced and manipulated in a computer program. They also provide a way of labeling data with descriptive names. So it is helpful to think of variables as containers that hold information. Their purpose is to label and store data in memory. This data can then be used throughout our program. So we've mentioned int and Boolean. In computer science and computer programming, a data type or simply type is an attribute of data which tells the compiler or interpreter how the programmer intends to use the data. Most programming languages support common data types of real, integer, and Boolean. And so there are a ton of lists of primitive data types. And basically it's all due to the number of bits or memory that you need when you write each one of these things. And so it takes a lot more memory to write decimal points, and there are certain primitive data types that can save you space when you're writing your code, but we're not worried about saving space in our games because we have plenty of memory to use for our game. So here we have an example of an if statement. This would be in Java, int x equals 10. So x has a value of 10. If x is less than 20, we're going to print out this is an if statement. So it's very simple, very straightforward, but this is just a simple example of an if statement. So now that we've created some enemy movement, let's go ahead and have our person be able to do a little bit more than just move. And so first, I want to organize my code, and I just noticed that I have these lines of code that I could leave in the act method and make one long string, but it's better practice, and actually the proper way to code is to separate out one specific thing per method. And so we are going to create our own first method by ourselves. So public is the amount of access this class will have. It'll be available outside of the class. Void is that we will not return anything. This middle word is the return type, what the method will return to the user. So when we move around, that is just doing something. You are not expecting a true or false. Like get x would expect an integer, is at edge would expect a boolean, because either you're at the edge or you're not at the edge. When you get your x value, you need the coordinate of that x value. But here we just are doing something. So we are going to cut and paste, and then we are going to call move around into our act method. And that way, if we want to add different things to our move around, we can simply do that by having it organized in your move around code. Okay, now we're going to create public void swat b. And so we're going to swat these b's and get them out of our hair. And so notice I have been using what we call camel case, and this is specific to Java, and it's just common Java syntax, and it's what they call Java naming convention, and you're supposed to use camel case, so lowercase on the first word and capitalize each preceding word, kind of like is key down. Okay. Now is key down, why the Greenfoot dot? And what that is that if we just looked in our actor methods, we don't have is key down. We need to access Greenfoot. So if we do Greenfoot dot, and then we get off it and we actually click on period and then do control space, it'll show all the methods the Greenfoot class has. So we can do Greenfoot dot. There's also get world dot, which will access, you guessed it, our world capabilities. So in our world class, we can add an object in, like we've seen before. We can, set the paint, set the background, show text on the background. You can do a lot of different things. Okay, get the width and the height. Get width, get height. Okay, so if you want to look at all of those in one kind of closed off library API, you double click on world, and then you can look specifically at the world class. Then you can kind of go back out to the tree, and it'll give you a list of all the different things that Greenfoot already has in a package, the Greenfoot hierarchy package, which has just a bunch of different classes that store information for us, so that we don't have to do quite as much work just starting out. Okay, and so swap B. So if your player is touching the B, so is touching B, and it's not just one specific B, it's any B, and any enemy. Okay, so not just B, I guess, enemy.class. Okay, so that would be any enemy that we have. So when we touch that enemy class, we need a way to reference the specific enemy that we're touching. So what we have this in our get world, we have remove object, and it's an actor, an actor object we can remove. Okay, and there is a way that we access an actor object. So right now we don't know that yet, but I'm going to show you. So we can, just like we name our person, main person, so we have a reference to that specific person. That's one that we kind of named and placed, but there's also ways that we don't just place it in. We can find and name something that the computer or the program finds for us. So actor found B would be the B that's touching the player. Okay, it will equal, and let's see what we have here. We could do get one intersecting object, and that would be of the enemy dot class. Okay, so if it's touching, we'll put found B, semicolon. And then don't forget to put in the act method. And don't forget the semicolon. Okay, so now our B's have been taken. So if we're touching an enemy, it will remove any enemy that it finds intersecting it. Okay. Now let's make this a little bit more fun. So if we go into our My World, we can create things that happen once the act button is pushed. So public void act, we made our first act method in our world class. So our actor automatically have the act method created for us. This is for our world that we're creating. So we're going to say if. So we're going to create if Greenfoot mouse clicked on anything or on nothing. We are going to add our object in, and we're going to add a new enemy. Now we're not going to name these enemies. We're going to have our enemies. We're going to do something new here. We're going to do a random number. So we can do greenfoot.get random number, and that expects the limit of the random number that you want to get. So let's, instead of putting a really long line of code, let's create a int random equals greenfoot.get random number. So let's make it a random x for a random width, and it's, well, let's change this. Let's change these numbers. Make it a little bit bigger for us. Make us a little bit bigger of a game. Let's do 7 by 7, and this should be get width divided by 2 and get height divided by 2. That way, no matter what we change the size, it will be in the middle. So if we do a random number, the width of the world, and then you can do random y equals get random number, get height, and we do it out here instead of in the method, because now we can use random x and random y at any point in our code, whereas when it's in the method you can only access it in here. That's why we probably later on will move this main person outside of the constructor, so that it's available throughout this whole My World class. So all you have to put is random x, random y, now we run it. If I click, they don't have a speed. So let's give them a little bit of a speed. And now I'm going to put my speed in the outside of the class. And so I'd be interested to see these change. These still have different speeds, although these are all in a line. Now they're all doing the same thing. We don't want that to happen. I was hoping they would move to different spots, but since our random X and random Y was done outside in the class, it just did it right when it was made, right when my world was made, and it always is the same number. So if we want it to change for each one of them, we would need to actually build those inside of the if statement, so each time it goes through it gets a new random number and a random X each time you click. So now each time we click, our X value is a little bit more random. Now it's always facing the same way, which I don't love. So we could always do enemy new enemy equals new enemy. So instead of doing that, maybe I'll not call it new enemy, but clicked, because it got clicked in, and then you can do clicked enemy, and you could also do clicked enemy dot set rotation to random X. Why not? It'll be fairly random regardless of what number we put in there. Okay, so now we have them popping in at all random locations and random rotations, and you can add a whole bunch in and have fun with it, and then you can go and collect them all. So we're collecting all these B's, and we'll go until we finish wrapping them all up, bounce around, and now they're gone.
So what I'd like to do now is actually remove these bees and set up a grid full of bees that I don't have to manually place in at the exact right spot. And so we're going to be learning about loops and also prepare and the constructor methods. And so if we go into our My World, the first thing we're going to do, so I know we did some work with this, but that was more of a teaching process. I'm going to go ahead and get rid of it. And the prepare method is being called in the public My World constructor, which is, like we've said earlier, is constructing the objects of class My World. And so in order to get a better understanding of it, let's take a look at what a constructor is. So a constructor in Java is a block of code similar to a method that's called when an instance of an object is created. So in our My World constructor, our My World, that background, is the object that is being created or constructed. So now we're back here in our constructor, our My World constructor, and now we don't have any class fields for it. That's why we've left these empty, and we're going to leave them empty for a little bit now. But we've added the prepare method inside of it. So while our prepare method is down here and it has a void, it is getting called in the constructor. So essentially it becomes part of the constructor with that. Okay, and so we might as well move both our our main person getting added in, and move it down into the prepare method. We should also add in the bees, and we're going to add them in a different way than we took them out. And here I'm going to show you how to do a for loop. So for int I equals 0. Okay, so this first part is giving you the starting value that we're going to use in our loop. And so iteration, I is going to stand for the iteration, is going to start off at 0. 0 iterations through the loop. And then how we will do this loop until what point. And so what is our limit? And so that's what I'm looking at here. What is our limit? What is our limit of our loop? And so let's say I just want 10. So our limit will be 10. And then how much are we adding up by? How much are we incrementing by? So that is your entire for loop right there. So this is a loop that will happen 10 times. I will start at 0 and go until it is not less than 10. So basically from 0 to 9, because we're adding up by 1 each time we end the loop. Okay? So first time through the loop, we are going to add object, new lowercase new enemy, comma, I times 20, and then that'll be our x value, our y value can be 50. Okay, and so if we save this, compile, refresh, you'll see that we have 10 B's stacked on top of each other, 50 on the y value, 20 pixels apart on the x value, and it'll start at 0. So if we stretch this, let's do 50 for everyone, you can see that they're stretched out quite a bit more. So if this is 0, this would be 50 for the x value, 100, 150, so on, all the way up to 450. And if I inspect, this x value is right at 450. And that is because the last time through the loop would be, this would be the first time through the loop. I is 0. We add it in. Then once after we've added the object, I will plus, I will be 1, and the new enemy will be located at 1 times 50, so the 50. Then after it adds that object in, it'll loop again, and it'll happen 10 different times. I at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 times 50. Okay? So actually let's stretch that out a little bit more and really get them evenly spread out across the page. Now in Greenfoot it's a little bit harder to show and demonstrate loops just because the act method is an infinite loop that will happen while the run button is pushed. Okay, so it's actually what you call a while loop, and so while the run button is being executed, the act method will continuously loop at 60 frames per second. Okay, now we're going to quickly jump into a nested loop, and what a nested loop is a loop inside of a loop. So if we wanted to maybe add in a grid, I use nested loops, and I can put a banner so that you guys can click on in my Frogger game, where you are able to have these blocks and design a map based off a nested loop, and it's a really quick and easy way to have a blocked map, so I encourage you to look at that game. Or the platform shooter game also has that. And so in order to do something like that, we would need to do a nested loop, and a nested loop just means that you have a loop inside of another loop. Okay, so for int j equals 0, j less than 10, j plus plus, what that means is we are going to loop through this loop 10 times. Now I could still add my objects in here, but it's also going to do this inner loop 10 more times. So this inner loop says count up, have j count up from 0 to 9, and that's all it's saying. But this loop is counting up I from 0 to 9 and doing this inner loop, which counts up j 0 to 9, 10 times. So this outer loop is happening and executing and making this inner loop happen 10 times, which this makes so that if I add in an enemy, object, new enemy, and we made them at I and j, multiply them so that they are visible. And so we saw with the x value, we can do about 75. And with the y value, we can also do about 75 will be the perfect number. just because I know if it's at 700 and this starts at 0, the max number for this will be 9. 9 times 50, or 9 times 75, excuse me, is about 675. So that's about the max it'll be, and so it'll go all the way to the edge, and you'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 by 1, 2, 3, 4, 7, 8, 9, and then there's 10 if you scroll down a bit. So you can see that all of a sudden we have a full map of bees. Now they don't have to be all bees, and there's other things that you can do to change it, and I'm going to show you that now. So let's go ahead and create an example of a map here. And so if we have a few different objects, let's have water, and we'll give it an image. Okay, water, sand, so instead of having these bees show up all across the grid, we're going to have our sand and water be located in specific spots. And right now, our sand and our water are a little bit too large for my liking. I would like to have 10 70 by 70 blocks for each of these. Okay, and so instead of having our sand be this large, we can go in, we can create sand. Remember, if you're not using the constructor outside of this method, you don't have to declare that it's public, but you can do get image dot and control space, and that'll give you the different options of methods that you can do inside of your image class. Okay, and so inside of your image class you can scale the image, and that'll give you that requires parameters of a width and a height. So what we said the width and height were 70 by 70. And this way, if I add it in, it will be a little bit smaller, and this will actually show up 10 by 10. We can check that real quick by doing an add object, new sand, and have it be the I times 70, J times 70, and we can see how this looks. Now there's going to need to be a little bit of some changes, and I'll show you why. Okay, so you have this, and it's kind of not exactly how you want it, and that's because the very first object will start off, and the middle of it will be in the 0, 0 position. So that is the very middle of the entire 70 by 70 block. We want the upper left corner to be in the upper left corner of our world. So if half of the block, if the sand block is 70 by 70 and half of it is going to the left inside of the wall and half of it's going up inside of the height, the top, then we need to do a addition of half of the height, which is plus 35, and plus 35, and I believe with order of operations you would not even need parentheses around it. That would just be a little redundant, but now you see this is a perfect block exactly in the upper left, and now your whole thing's full of sand. But let's say we want to have some of it have sand, some of it have water, maybe different blocks, similar to our Frogger game, where we do this in great detail. I'm going to do this quickly for you now. We need to store each position along this top row. Also, we're going to need to store each position along the entire grid. Okay, so if I wanted all of these to have water instead of sand, we need a way of storing all of this information. Okay, and that's where we're going to create an array. An array is a set list of variables stored in a data set. So if I have a list of, let's say as a teacher, I have a list of different test grades. Okay, one array might be all of my students' grades on test 1. The next array might be all my students' grades on test 2. Okay, and so, student 1, maybe they got 100 on the first test. Student 2 got a 90 on test 1. Student 3 got an 80 on test 1. And then on test 2, student 1 got a 70. So that would be an entirely different set of data. Okay, maybe student 2 missed the test or got a 0 on it because of cheating or something. That would be an entirely different data set. But if we're trying to get the average of all of student 1's grades, or maybe the class average of all of the tests, we need to be able to access both test 1 and student 1, 2, and 3, test 2, student 1, 2, and 3. And in that situation, we're going to need a multi-dimensional array. Okay, so a multi-dimensional array is a list of data sets. So a multi-dimensional array is a list of data sets. What that means is it's a list of lists. Okay, so first I'm going to show you how to do, let's do int top row. Okay, and so what we can do here is this is going to be our top row, an array that'll set up our top row. Okay, so our top row needs to have different values, and we're going to use integers so that we can cycle through them and choose, if we had 4 or 5 different background land types that we wanted, objects that we wanted in there, we could use different numbers. But right now I'm going to use 0, 1, 0, 1, 0, 1, 0. Okay? And actually we're going to need 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So now we have our top row. So since it's a top row, I'm going to have the height just be 35. And our I value is cycling through each one of them and should place a new object in there, okay? But we're going to say if top row I equals 0, that's where we will place sand. Now, our top row has, remember, a list of variables stored in a data set. So this is our just array, our single dimensional array. It has a list of 0s and 1s. Okay? And so top row 0, top row 1, top row 2, etc., all the way down to 9. So this would be top row 0 would be 0. Top row 1 would be 1. Top row 2 would be 0. Top row 3 would be 1. 4 would be 0. So on all the way up to 9 would be back to 1. Okay? So when we utilize this loop for I will be changing. So I will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I is equal to 0, which we've said, this will return a 0 or a 1. So if it returns a 0, this will be a sand, this will be sand, this will be sand, this will be sand. And this one will also be sand. The 1s will not have anything show up right now. Okay? So we got 0, 1, 0, 1, 0, 1, 0, 0, 0, 1. And you can see that matches with the array that we have up top. Okay, so let's make it. We'll do a copy, paste. If I equals 1, we can do new water. And now, if the top row, where there are 1s, 0, 1, 1, 1, and 1, these will be replaced with water now, because we've said if the top row, if the location, if the value returns 1, we'll put water in. Now, the water has not been resized. So we can go into our sand, copy and paste the format, change this sand to water, compile. Now you can see it looks nice. Okay, you can see they're in the right place. So what we can do now is change this top row. Let's just change it to map and have both a two-dimensional array now. So now this needs to have not just one list, but we need a list. We need 10 numbers, and we need to have that a certain number of times. So we need to have 10 numbers happen, 2 or more times. And you're going to have a comma, not a semicolon, after each one of these sets. Okay, and then you Control-Shift-I, organize it a little bit better. Move all of these with a couple tabs. And then now you have your list. And then instead of top row, you're going to want to put map I and J, map I and J, and you want to make sure that your water, we replaced the J, what we had before, with a J times 70 plus 35. So you want to copy and paste and make sure that's on both spots here. So this is what your code should look like in the end. Okay, and then that will utilize this map to build. Oh, you need to switch your J and your I and J. Okay, and so now you can see the rows and the columns are getting organized. And now now that you have it set up like that, you can manipulate it to be however you would like. Maybe you want water all the way across the bottom here. And the coolest part about this, okay, so we have water all across the bottom. We changed a few things over here on the left. Coolest part about this is that you can add in 4 or 5 of these, and you can keep adding in different numbers. You could add in a 2 and a 3 and a 4, and all you need to do is if map is 2, is 3, is 4, you put in those new objects. Okay, so this is a cool, fun, fast way to be able to design a 2D map in Greenfoot. The last thing I'd like to do is do a set paint order. This is a method in the world class that will set the paint order based off the classes you put in the parameter here. And so we want our person.class to be the first thing to show up, then our enemy.class, and then our sand and our water should be pretty evenly lined up because we scaled them both, and so it really doesn't matter if they're above anything else. And so now we have our person, and if I run it, you can add these enemies in, and we can collect them and do different things. If you wanted, you could make it so that your water is something that you can't walk over, or maybe you move slower because you're swimming through the water, or something of that nature. But we kind of have a little simple simulation, a little simple game that we can work with. So that's it for the Greenfoot Crash Course. I hope you guys got a quick overview of some of the basics in Greenfoot. If you need a lot more detail, we can go to my 6-hour beginner course, which allows you to do some examples and utilize a lot of these different methods and things that I've created. This was just a fast version of the basics, so if you have a little bit of experience, maybe this is something simple and easy and quickly to go through so you can get used to Greenfoot and get going on to more advanced stuff. Hope you guys enjoyed.